All right, today we're going to talk about this thing called thermochemistry. This will just be a quick introduction to it. Um, there is a Quizlet set that I will post in the description of the video. So all the vocabulary today will be in that Quizlet set. All right, let's get started with this thing called thermochemistry. So the first thing is, what is thermochemistry? If we're going to be talking about it, we really should know what it is. If we look at the root of the word, this thing therm right here, it comes from the Greek word which means heat or hot, depending on if it's therm or thermo. Therm means heat, thermal means hot. Um, Things like thermometer measures heat, actually measures temperature, but we say it measures heat. That's what the word thermometer means, or a thermos, right? It's a thing that you use to keep your drinks warm. That's your thermos. It comes from that same root word therm. Chemistry comes from a Latin word, actually comes from the same root as alchemist. But chemistry is, we're looking at changes and interactions of matter. So if we put those two things together, therm and chemistry, we're talking about thermochemistry. We're looking at the heat or energy changes that occur during chemical reactions. So when we talk about thermochemistry, we're looking at the heat, we're looking at the energy, and how those things change as matter is changing. Another word that you might hear when you're talking about thermochemistry is this other one called thermodynamics. Has that same root therm in it, right? We're dealing with heat, but now we're just looking at, it's the study of how energy is changing, right? We've talked before about how energy is changing from one form to another. That's what thermodynamics is looking at, is how that energy is changing from one to the other. We're going to talk mostly about thermochemistry. We're looking specifically during a chemical reaction, how is energy changing? But you might see thermochemistry, thermodynamics used interchangeably online. So I want you to be familiar with both of those terms moving forward. Just to hit some definitions, make sure that we're all on the same page. A review from before: energy is the ability to do work or to cause change. And that causing change is what we're really interested in chemistry, right? We're looking at the causing change. Work is a physics term, meaning it's a force that's causing something to move. We're more looking at how matter is changing in chemistry. And again, the conservation of energy, or the first law of thermodynamics, right? Studying how energy is changing, is that energy cannot be created, cannot be destroyed, but it can be converted from one form to another. We'll talk more about conservation of energy in future videos, and we'll look at other laws of thermodynamics later on as we move forward in the next couple of videos. So looking at heat, let's get a good definition of the word heat, because it's a word that we use a lot in everyday language, but it's not really something, at least scientifically, that we have a great understanding of. So let's look at heat. When we say the word heat in science, especially in chemistry, we're looking at energy being transferred from one object to another because there are differences in temperature. Something is hot, has a higher temperature. Something is cold, it has a lower temperature. As that energy is transferred from one to the other, because of those differences in temperature, that's what we call heat, okay? And we measure, again, just to review for temperature, okay, when we're measuring temperature, what we're really looking at is the average kinetic energy of the particles in our sample. Whether it's a solid, liquid, gas, doesn't matter. We're looking at the average kinetic energy of those particles being the temperature. So if something has more kinetic energy, so another thing has less kinetic energy, if we bring them close enough together, that high kinetic energy is going to be transferred over to that lower kinetic energy, and that's what we call heat, right, as that energy transfers. Now, a review: temperature we can measure in 3 different scales: Celsius, Fahrenheit, and Kelvin. Fahrenheit we don't use in science. Kelvin we use a lot when we're talking about gas properties and gas laws, but moving forward, using Celsius temperatures is just fine, right? Because you'll see we're looking at the difference in temperature, and so a Celsius temperature scale is just fine. Now, in case this isn't confusing enough, right? The abbreviation that we use for heat, the variable that we use for heat, of course, why not, is lowercase q, right? Yep, yes, lowercase q is the letter that we use to abbreviate heat. I don't know if you know this, because in Latin, the word heat starts with a Q. No, that's not right. I just made that up. We just do. It's something that we just do, right? Heat. Whenever you see a lowercase q in an equation, especially in chemistry, we're talking about heat, right? Energy transferring from one object to another because they're at different temperatures. All right. Last video we talked a little bit about chemical energy. Let's talk a little bit more about it, review, and then get into a little bit more depth. So chemical energy, we're talking about the energy stored within chemical bonds. In order to hold two atoms together, that requires some energy, okay? And then when that bond is broken, that energy is released. Well, it requires some energy to break it, and then when you make the bond, right, it's going to require, so chemical reactions involve breaking and making of chemical bonds. And so we have to look at, and we'll talk more about this in future videos, we've got to look at how much energy does it take to break the bond and how much energy is released when we make the bond, and how do those differ. Like I said, we'll get into those in some future videos. And so when we're talking about chemical reactions, it's a net absorption or a net release of energy, which we see as heat, okay? Now, I use the word net because, again, it requires some energy to break the bond, and some energy is released when those bonds are made again. And so so we have to look at the net. We've got to look at the cost, the energy cost of breaking the bonds, and the energy released when we form new bonds. Again, we'll talk more about that in depth in future videos. If we're looking at the flow of energy, because that's what heat is, right? It's a flow of energy from one object to another. Let's say we have a Bunsen burner here, and on top of the Bunsen burner, we put a beaker. There's a solution in there, and we want to heat, we're going to heat that solution, okay? Now, is this, using some vocab words from last video, from before, is this an exothermic reaction, or is this an endothermic reaction? Okay, now take a minute and think about it. Is this exothermic, or is this endothermic? Now, some of us are gonna look at this and think, oh, of course, this is exothermic, right? Because that fire is releasing heat, it's releasing energy. The flow of energy is outwards, it's away from the source of the flame. And so, of course, this is going to be exothermic because the heat or the energy is flowing away from the flame to the environment, to its surroundings, to the universe, as we say. Okay? Of course it's going to be exothermic. Well, I'd like you to look at it from a different perspective. Okay? What if, instead of looking at the flame, what if instead we look at the solution in the beaker? What's the flow of energy for the solution in the beaker? Well, now that flow of energy is inwards, it's towards, it's inside, towards the inside of our object. And so this is an endothermic reaction because heat and energy is flowing from the outside, from the environment, into the beaker. So even this simple example where we're heating a solution, is it exothermic? Is it endothermic? It might not be as simple as you think. Let's define a couple of words here and then we'll go back to that example. What I just illustrated is it hopefully demonstrates the importance of defining what we call the system. Okay? The system is the part of the universe that we are focusing on. In the example we had before, are we focusing on the Bunsen burner? Are we focusing on the flame? Or are we focusing on the solution? Are we focusing on the beaker? The great thing about this, about looking at energy and the flow of energy from one thing to another, is we get to define the system. We get to make it whatever we want. We can make it as broad as we want, like the planet, or we can make it as narrow as we want, as specific as we want, say, a specific molecule or atom. We get to define the system. The environment is everything that's outside of the system. The entire universe that is outside of the system that we're focusing on. So if we're just looking at our planet as our system, the environment is going to be the solar system, the sun, the other planets, stars, comets, the moon, anything that's outside of our planet. But if I want to define my system as my hand, that's my system, then everything else is going to be my environment. My headphones, my arm, the table I'm sitting at, the chair I'm sitting on, the planet, the sun, the rest of the universe, right? That's all going to be the environment. So it's very important that we know what is our system, what is our environment. Perspective matters. If my flame is my system, then right, the energy is flowing out, it's flowing away. So of course, this is going to be exothermic. Heat is flowing from the flame to the environment. But if I adjust my system, if I change my perspective, if I alter my focus, and I say, all right, now my beaker is my system, now the flow of energy is inwards. So now this is going to be an endothermic reaction because the heat and energy is flowing from the environment into the beaker. So it's very, 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 very important that we understand our perspective. What is your system and what is your environment? Right, so that's the lesson for today. If you guys have any questions, feel free to drop them in the comment section below. Make sure you hit that like button and the subscribe, and I will see you guys later. All right, have a good day. Bye.